Hello everyone, this is Johan Koskinen recording from Melbourne, Australia. And here it's winter. Would have loved to be in Petersburg, but here we are. So I'm going to just talk you through some things that we've been doing with Nikita in a project that is funded by the Russian Science Foundation. And so it's me and Pete Jones, a former PhD, is now doing a postdoc at Manchester, and several people, Artem, Ksenia, and Darkhan, who have been working on different aspects of this project. So I put in the abstract to remind myself of what I'm going to talk about. So I'm not going to read this out. I just want to highlight the two operative words here. One is that we are looking at ways in which you can analyze so-called socio-semantic networks, socio-semantic data part here. But in this project, Nikita and company are introducing another entity that we want to try and incorporate, and that is a static semantic network, an additional semantic network that we're just going to keep as some kind of a predictor for modeling other aspects of the socio-semantic network. So the context is, this is flood management, and these are all pictures from an island in Oxford where I used to live, Osney Island. So if you can see, here is Osney Island, and here we have Bridge Street. I lived there for a few years. Lived a few years here on West Street as well. And as you can see, there are two waterways here going around Osney Island. One is the Thames, the River Thames that goes down to London. And the other part here is a little canal. So I think originally this might be the original Thames, and the other one is another river. I don't know. So it's a very low-lying island, and we would have, not every year, but several years, we would have flooding, and they will put up flood defenses. And what you see here in this picture is the actual River Thames, and how they put up these flood barriers here. And the Thames side very rarely flooded, or it didn't flood as quickly as the other side, where we have this little waterway going at the back here of the island, which is here is a picture of that. So that was more commonly flooded, and one of the reasons was the outlet of water from the River Thames into this little waterway here at the back. And so they worked on various different ways in which you could try and prevent flooding, both in terms of putting up barriers, but also in managing the waterways. Now, what I didn't know, and I don't know, is that apparently there are, of course, government agencies and councils that manage floods and flood responses, especially in the UK, but there are local actors that are not experts as such, but form little flood management communities. And here we're going to try to look at these local actors in these local flood management communities and the ways in which they use signs or concepts or words related to flooding. So we have a number of local actors, and we have a number of signs. So we can look at directly how these actors use these signs in a two-mode network, in an actor by sign network. Of course, what the literature, what they're interested in the literature is the ways in which these signs are connected in the local knowledge network, how different signs tend to be used together with other signs, such as for people in flood, people in risk, etc. here. And there are standard ways in which to derive these local knowledge networks from corpus or word usage by these actors. If we want to add a social part to this semantic structure, we can introduce the social network. So that's network amongst the actors that reflects communication, interaction, something that is meaningful from the perspective of these individuals, let's say, create their local understanding of these concepts and how they're interrelated. So this is more or less the iconic or sort of canonical form of a socio-semantic network. And then, you know, Nikita is not the first one to come up with the idea of a socio-semantic network. But I think to structure it in this multi-level network, where we have 2 types of nodes and 3 types of ties, is something that I think I can say that Nikita has pioneered. So together with lots of other collaborators, he's looked at analyzing these socio-semantic networks as multi-level networks. Now, in this particular project, there is the additional challenge of also trying to take into account an additional semantic network with an overlapping set of signs. So we will have flood and people and risk in both of them. But the ties between these signs, so the concept pairs, do not necessarily need to be the same. So we can have a partially overlapping network. And this network that we're going to refer to as A, we can think of that as an expert semantic network. A network that has been derived out of word or concept or sign usage by people that are professionals in terms of flood management. And we're going to treat this network as exogenous and given in the rest. And we're interested in seeing how the interplay between how people connect words locally, both as a result of how they are seem to be related by the expert, but also how they are constructed with reference to the local usage of these terms. So the bottom part here, yeah, we have for any method that can handle multi-level networks, cross-section, longitudinally, or using block models, we can analyze the sort of canonical form of a socio-semantic network. Of course, if we just want to compare the local knowledge network, so the knowledge network of the local actors with the expert semantic networks, we can use any standard approach in network analysis for analyzing multiplex networks. Of course, can we put all these together in one framework? That's the challenge. So I'm going to just very briefly sketch 2 ways in which we can start thinking about doing this. And the first is to depart a little from the canonical representation of the socio-semantic network and think of what these ties here in the local knowledge network actually corresponds to, what they're based on. As it turns out, often the local knowledge network is derived out of analysis or readings of the usage by these actors. So these actors, they provide something we can call individual meaning structures. Right? So if we have 3 individuals, they might have 3 individual representations of how these signs relate to each other. So they all have their little semantic networks. In the past, what has often been done when you wanted to create the local knowledge network, so the pooled representation of the local knowledge across actors, is to include all concept-concept pairs that have been reported by at least 2 actors. But we can use the disaggregated form. We can think of, well, maybe we want to analyze each individual person's semantic network in this context. Now, then we have 2 quite difficult issues to deal with. So one is, how do we relate these individual actors' semantic networks to the expert network? How do we compare those? Because we have 3 different networks. I want to compare to one sort of criteria network. Also, And a much more challenging proposition is how do we actually compare or link these semantic networks of these actors across individuals? That's, if you think about it, is actually not a trivial problem. So how do we take into account that, say, actor 1 and actor 2 have a social tie, and actor 2 and actor 3 have a social tie, but actor 1 and actor 3 might not have? How do we take that dependency into account? Well, you can think of this as actually being an instantiation of a network of networks. And this is something that we've tried to define and expound upon in an article under or in preparation that we're working on. So why do I say network of networks? Well, we have one overall network, that's the social network. We have person 1 has a tie to person 2, person 2 has a tie to person 3. There's no tie between 1 and 3. So that's a network. But what this network connects is not only individuals, but it also connects individuals' perceptions or views of these semantic networks. So the semantic network of person 1 is connected to the semantic network of person 2, but it's not connected to the semantic network of person 3. So yeah, we can think of these as a network of networks. So how we're going to represent that is that we're going to transform the network of networks into one multi-level network. And the key here is a very subtle change that we're going to still have individuals and their social ties, but we are not going to represent the signs themselves. We're going to represent the links in their semantic networks as nodes. So if you see here, risk village, that corresponds to the tie between risk and village here, and people floods is for person number 1 is this tie people flood. So each concept pair, each link or potential link is represented here by a node. So we can simultaneously represent the ties among people and the ways in which they connect different signs. Now, this also means that we can actually also incorporate the expert network. Because the expert network can also be represented as a collection of not nodes, but as a collection of links. So we can take all links here. People manage becomes a node, people manage flood becomes a node here, flood manage, etc. Now, how do we indicate that there is any overlap between a individual meaning structure and the expert network? Well, there is overlap if an individual nominates a concept pair, flood risk, that is also present in the expert network. And we can denote that, or we can indicate that by having attributes on these top level nodes here. So risk village, people floods, people risk, flood village. None of those ties are actually in the expert network. But we see flood risk is in the expert network. So by using attributes on the top level nodes here, we can represent simultaneously the expert network, individual meaning structures, and the social network. And if you have been working a bit with graphs, you realize that you will quite soon have lots and lots of nodes in your network if you transform each pair into a node. So that will grow like n squared. But there's no real need in our analysis to include isolated concept pairs. We don't have to retain all of the pairs. So we can prune that down to the ones that actually just are used. And now we want to take into account that these top level nodes here, like people flood, people risk, that they, to retain some of the structure that we have in the original network, we want to, these nodes should not be arbitrary. We want to connect those nodes that actually share a sign. And why do we do that? Well, we do that so that we know that if a person says people in risk is connected and people in flood is connected, now that forms like a 2-star in the individual meaning structure, because here we have 2 links that are connected through one node. And we can indicate that by drawing a line in the top level network between all nodes that share a sign. So that gives us, as you will see, a suite of configurations that will map the original representation of the semantic networks to the new representation in terms of a multi-level network. For example, we can think of representing alignment between individuals in the perception of how concepts are related. So if we have people that nominate the same link in the semantic network, they connect people in risk, then that will translate into this 2-mode star in the multi-level network. You can call that co-usage. But perhaps more interesting is when we also incorporate the social information. So if we have 2 people that nominate the same concept pair, say people risk, and they are also socially connected through a social network tie, then that becomes represented by this multi-level triangle here, where we have 2 people that are socially tied and nominate the same or concept pair. And this is, we can think of as a direct application of Heider's POX scheme for balance. So if people are, if they like each other, they should also like or nominate the same concept pairs. You can also think of various forms of selection and contagion, whereby individuals that are connected are more likely to use the same same terms together. Or it could be that people that use the same language are more likely to also become socially tied. And of course, in terms of symbolic interactionism, there's a lot of literature on the social construction of knowledge. And here we have the social and we have knowledge. And we can further extend on this by thinking of all sorts of different processes in these combinations of social ties and individual meaning structures, and how they play out over time and how that's represented in these multi-level configurations. What if, for example, we have 2 individuals where both relate the concept of risk to something? The one person relates risk to people, and the other one relates to the risk to flood. Now, if over time they will, we expect people that are socially tied to start using the same quote-unquote language, we might go from this situation, which is represented here on the left by a multi-level 4 cycle, to the situation here on the right, where they use the exact same terms, which is here in this coat hanger configuration. So this is a reconfiguration where you use related concept pairs, but over time you might start using the exact same. You can also think of more advanced types of patterns over time. For example, if we have an extra dyadic effect in terms of the construction of knowledge. So if we allow for, I'm going to flip back, if we allow for this phenomenon that people that are socially tied tend to use the same concept pairs, then we might have a dyadic pressure for pairs of individuals to use the same concept pairs. But what if there's an extra dyadic one, and the pressure that goes beyond the dyad, so that the usage of the same concept pairs is not just the sum of the individual diets or the pressures for individual diets. So one way of representing that could be by seeing situations where we have three individuals that are in a clique, and that they over time they conform to choosing the same concept pair over and above what we see in the dyadic alignment. So we could, for example, model this by assuming that we have the dyadic alignment or social alignment. So we have these 1, 2, 3 pairs that will contribute to putting pressure on them to select the same concept pair. But if we in addition want to have an extra dyadic effect, what if we have a negative tendency for individuals to sort of pick out or stick out and pick concept pairs that no one else has related to? Well, putting these two effects together, we would expect to see something like this triadic pressure over time. Now, I said that we was going to try to accommodate the fact that we have an expert network, and we can, in our representation, we represent the expert network by binary attributes on the top level nodes. Then it is possible to model more complex multiplex structures. For example, if we think that local actors, they might connect to concepts directly, if they're indirectly connected by experts, then in the multi-level framework, we represent it by this kind of coat hanger structure here. That people tend to choose concept pairs that are embedded in a triangle with concepts that are nominated by the experts. And we can look at the reverse as well, where local actors indirectly connect concepts, people, and risk that are directly connected by experts. Then that will be represented by this marked 4 cycle with a chord here, where people connect to, again, a cluster of 3 concepts where one has been nominated by experts. So, just as a very quick example, and this is something I borrowed from the paper that we're working on, where we have tried to represent a number of these types of processes that correspond to the social construction of knowledge, or the local knowledge network. And we have analyzed that using a multi-level exponential random graph model. This is all now fitted in a standard program in MPNet. So this model table, or these table results, comes in 2 parts here. So let's just focus on model 1 here and what it tells us. Well, the first 3 effects here are just standard network effects for the social network, where the one effect that is significant here is the clustering effect. So there's an alternating triangle effect that are positive. So we have just a very, very small model for modeling the social network. And then we have a number of effects for the 2-mode network. Remember here, 2-mode means that it's people selecting concept pairs. So for example, the X edge here, that is the standard density effect for a 2-mode network. And the sufficient statistic for that is this configuration here. This configuration just corresponds to individual dyads that are reported in the individual meaning structures. And then we have things like the popularity of concept pairs. So you see here there's not that much heterogeneity in this network. So there are no concept pairs that are sort of overrepresented in the individual's representations. Here we have something XACA, which corresponds to this 2-mode structure here, and that is co-mentioning of possibly distinct concept pairs across actors. So there is a clustering here that if an actor tend to say connect S and U, you also tend to connect V and T, and that goes for across all of them. Now going down, continuing with the model 1 column, we see that yes, we do have a network of networks effect here, where people tend to nominate the same concept pair if they're also socially connected, or vice versa, that they become socially connected if they nominate, say, concept pair. That would correspond to this original representation in the original network of networks. And then we also have a positive effect for people tend to nominate concept pairs that have concepts or signs in common. So this 2-star effect. Now, I'm just going to quickly point out this negative effect here. So there's a negative effect for this 4 cycle. And this 4 cycle, I said, that was something that we expected this to be sort of less than chance, because this should be recombinated into a triangle. So we expect there to be pressure for this to be to sort of collapse, to not be sustainable. And we find that indeed, if we don't take the expert network into account. In the second model here, we do include the expert network. Of course, there is an alignment between the local actors and the expert. So you tend to choose the same concept as concept pairs as the experts. But what happens when we include that is that this instability of the 4 cycle disappears as a significant effect. So in the 2 minutes or so that I have remaining, I'm just going to briefly show you, okay, what do we do if we want to do this over time? Now, can we model all of these networks together if we don't disaggregate the local knowledge network? And yes, of course you can. And this builds on work that lots of people are doing at the moment. For example, James Holloway, where we take these individual networks, the local, the expert, the local knowledge network, Z, the social network, Y, the sign usage, so people buy signs, and the expert network, and put them into these blocked matrices where the zeros indicate that we have structural zeros. So that means that we can model change over time in the local knowledge network. Here, type can disappear and appear, and changes in these usage, where you nominate signs, and also changes in the social network. So that's quite simply just putting everything in as 3 dependent networks, say in RCNA, using the expert network as a covariate network. And here is just a quick example of what it might look like. So we're modeling 3 networks: the local network, so local knowledge, the social network, and the usage network. First, we don't find any effect here of this multiplex closure. But we do find that people tend to, or that signs that are nominated together tend to be connected, which is almost circular. Now here with another model where the difference is that we have used a slightly more appropriate model for the social network and the other network. So here we have, undirected ties, which is important to take into account. And we don't find any real differences. These were very simple models, and of course we can expand on these using already available terms in RCNA as well as various interaction terms. So we can start looking at various forms of combinations of science usage and social ties. So yeah, we just quickly illustrated how we can think of these this overall data structure as a network of networks. And this can of course be extended to longitudinal analysis using any package that can handle multi-level analysis. Now, if we want to do more advanced multiplex analysis, yes, then we might want to consider this second way of representing it. And what we have to do then is to use the usage network rather than the individual meaning structures. And I'm done. Thank you for listening.